Welcome everyone. I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy, Muradnagar. The topic is regression, and it is thus part 2 of this previous lecture, and this is lecture number 10, and the topic I again tell you regression part 2, and the subject is biostatics and research methodology. Code is 801T. The course is Bachelor in Pharmacy, and the university is Dr. APJ Abdul Kalam Technical University. Now, the content of my this lecture is, we first find the fitting lines y equal to a plus b x, that is the regression line y on x, and the another fitting line x equal to a plus b y, that is the regression equation of x on y. And the second, I will explain in this lecture multiple regression, and in the last the standard error of regression. So, how we find the regression equation in individual series using normal equation. So, we will learn in now regression equation in individual series using normal equations. This method is also called least square method, because in this we minimize the sum of the square of the distances or residuals. Under this method, the regression equation can be calculated by solving two normal equation for a regression equation. So, if we have a regression equation y on x, this is a y on the if we want to find the regression equation y on x, the regression will be equation will be y equal to a plus b x, and to find this linear regression equation, we should have the value of a and b. The a and b value can be calculated by the two normal equations. The normal equation, first normal equation equal to summation y equal to n a plus b summation x, where summation y is the sum of the y values and capital N is the number of observation, and summation x is the sum of the x variable values. The second normal equation is summation x y equal to a plus, so a summation x plus b summation x square, where summation x y is the sum of the product of values of variable x and y, and summation x square is the sum of the x square values. That means, we first square the x values, then we find the sum. So, to find the regression equation y on x, the regression equation y is equal to a plus b x, and these are the two normal equations, summation y equal to n a plus b summation x, and the second normal equation is summation x y equal to a summation x plus b summation x square. Summation means total. Similarly, for the regression equation x on y, it will be equal to x equal to a plus b y. So, x equal to a plus b y is the regression equation of x on y, and the two normal equation for this are summation x equal to n a plus b summation y. Second normal equation is summation x y equal to a summation y plus b summation y square. So, to understand this, we take a example how we find a regression equation. We have another method to find the regression coefficient or value of b and a with the help of this formula. The regression coefficient of y b y x is equal to x summation y minus summation x into summation y upon n into summation x square minus summation x whole square, and the value of a calculated by y minus b x. Here A is the y intercept, indicates the minimum value of y for x equal to 0. That means, A is the value of intercept when value of x equal to 0, or you can say it is the minimum value of y when x equal to 0. B is the slope of the line and it indicates the absolute increase in y for a unit increase in x. That means, B is the regression coefficient or slope. It tells us कि अगर हम x में 1 यूनिट का इंक्रीमेंट करेंगे तो y की वैल्यू में कितना इंक्रीमेंट होगा, ये उसका आंसर देता है एंड इट विल बी इक्वल टू द y. सो it is b equal to slope or regression coefficient. So, to understand these formulae, we take an example. A drug seems to be decomposed in a manner such that a drug seems to be decomposed in a manner such that appearance of degradation of product is a linear with time, and this is equal to C D equal to K T, C D equal to K T. C D K T, C D K T at x. So, here we have two variable, one is time and second is degradation of the product. As we know, degradation depend upon the time. So, the drug decomposition, that is y variable, we take as dependent variable and time as independent variable. So, in this example we have when time is 1, the value of y is 3, and when the time is 2, the value of y is 9, and when x value of x is 3, the value of y is 12, and when the value of x is 4, the value of y is 17, and when the value of x is 5, the value of y is 19, and we want to find a regression equation of y on x here. So, to find the regression equation, that means here we want to find the regression equation y equal to a plus b x. To find the regression equation, we want to find the values of a and b, and the value of a and b calculated with the help of two normal equation, and the two normal equation are, first normal equation is summation y equal to n a plus b summation x, and the next normal equation is equal to summation y x y equal to a summation x plus a b summation x square. So, to find the values of summation y, summation x and all these terms, we first find the sum of the x values. we कैसे फाइंड करेंगे, सबसे पहले हम x का टोटल फाइंड करेंगे. द वैल्यूज ऑफ x राइट इन ए टेबल फॉर्म 1 plus 2 plus 3 plus 4 plus 5, this will equal to summation x. Then we find the value sum of the y, that is we total the values of y and we get the value of summation y. Then we find the value of summation x square. To find the value of summation x square, we first square the values of x, that is 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, and then we find the total. So, summation x square is equal to 55. Now, we find the y square. To find the y square, we first square the values of y, that is 3 square 9, 9 square 81, 12 square 144 and so on, and then the total of y square equal to 884 or you can say 884. Now, we find the sum of x y. To find the sum of x y, we first multiply the value of variable x with the value of variable y. The each corresponding value of x multiplied the corresponding value of y. 1 multiplied by 3 equal to 3, 2 multiplied by 9 equal to 18, 3 12 ja 36, 4 7 ja 68 and 19 5 ja 95. Now, we add these terms and find the total, and this will be equal to summation x y. So, first to find the value of a and b, we find these values, then we put these value into two normal equation. So, as the first normal equation is summation y equal to n a plus b summation x. So, summation y equal to n a plus b summation x. So, the summation y, if you see here, summation y equal to 60, n are the, as I told you already, n are the total number of observation. So, in our sample there are 5 samples, 1 2 3 4 5, only 5 samples. So, n equal to 5, 5 a plus b, we write it as and summation x equal to 15. This is summation x equal to 15. On rearranging term, this equal to 5 a plus 15 b equal to 60. So, this is the first equation, and the second normal equation we know as summation x y equal to a summation x plus b summation x square. The second normal equation is summation x y equal to a summation x plus b summation x square. So, here we put here the values of summation x y. The summation x y is equal to 220. If you put here 220 a multiplied summation x, that is 15, plus b summation x square, that is 55. On rearranging these, we find the equation like this: 220 equal to a plus 15 a plus 55 b. So, the second equation is 220 equal to 15 a plus 55 b. Now, to solve these two equations, as the first equation is 5 a first normal equation is 5 a plus 15 b equal to 60, and the second equation is 15 a plus 55 b equal to 220. These are the two linear equation, simultaneous equation, and we want to find the value of a and b by solving these two equation. To solve the equation 1 and 2, we first multiply the first we equating the coefficient of a by multiplying the equation 1 by 3. So, it becomes 3 5 is 15 a plus 45 b equal to 3 6 is 18, 180, and now we subtract, and now we see here the coefficient of equation 1 is 5 and the coefficient of equation a equation 2 of a is 15. So, first equate the coefficient of a by multiplying equation 1 by 3 and subtract these two equation. On subtracting these two equation, this will be cancel out and this will be equal to 10 b equal to 12 minus 8 4 40 and b equal to 40 by 10 This implies b equal to 10 4 ja 40, b equal to 4. So, we get the value of b equal to 4. So, now to find the value of a, put the value of b equal to 4 in equation 1, put b equal to 4 in equation 1, this will be equal to 5 a plus 15 b, b is, this is first equation. So, 5 a plus 15 into 4 equal to 60, and if you saw this is 5 a equal to 60 minus 60 and 5 a equal to 0. So, a equal to 0. So, in now we get the value of a and b. So, a equal to 0 and b equal to 4. We now put these two value in our regression equation. Our regression equation is y equal to a plus b x. Our regression equation is y equal to a plus b x. So, a is 0, b is 4 into x. So, this is the required equation. You can write it as also y equal to 4 x. This is the our required equation, y equal to 4 x. This is the our required regression equation, y equal to 4 x, and here the value of a is 0 and value of b is 4. So, we find the regression equation like this. The another term is multiple regression. Multiple regression is a analysis, is a powerful technique used for predicting the unknown value of a variable from the known value of 2 or more variable. So, if we have 2 or more independent variable and we want to predict the value of one dependent variable, we apply multiple regression. For example, if we want to predict a person height on the basis of their age and gender. So, here we have two independent variable, gender and age, and the dependent variable is age. So, in this condition we apply multiple regression. So, the variables, independent variable are also known as predictors, because they predict the value of dependent variable, or sometimes they are also called explanatory variables. So, multiple regression, it is a method used for studying the relationship between a dependent variable and 2 or more independent variable. And the purpose, what is the purpose of the multiple regression? The first purpose is multiple regression is prediction, because with the help of multiple regression we can predict a value of dependent variable with the help of 2 or more explanatory variables. Second, the objective of the multiple regression is explanation. Explanation, that means we can explain how much change in dependent variable with the change in the independent variables. For example, how much change in a height of a person with the change in their age and their his or her gender. The third is the main purpose, another purpose of the regression is multiple regression is theory building. With the help of some explanation and result, we can build the theory. The variable whose value is to be predicted is known as dependent variable, as I have already told you, and the one whose known values are used for prediction are known as independent or explanatory variables. What are the design requirements for multiple regression? For multiple regression, there should be a one dependent variable which is also called criterion. So, for multiple regression we should have one dependent variable which is also called criterion, and second thing we should have two or more independent variables which are called predicted variables or explanatory variables. And the third important thing for multiple regression, the sample size. The sample size generally less than or equal to 50, but when we calculate the sample size for multiple regression, it should be the 10 times of as many cases of independent variable. For example, if in our study then we have two independent 3 or 4 we have 3 independent variable, for example, age, weight, gender. Then if we have 3 independent variable and we want to predict the height of that person. So, if we have 3 independent variable, we should have 10 into 3, that is 30. The sample size would be 30. So, the main important thing, the sample size generally less than or equal to 50 and it at least 10 times as many cases in independent variables. In general equation, the multiple regression equation can be represented y on x1, x2, xk is given by a polynomial y equal to a b1 x plus b2 x square plus b3 x3 plus b4 x4 and so on. And if we have one independent variable, then the regression equation will be equal to y equal to a plus bx, and if we have two independent variable, then the regression equation will be equal to y equal to a plus b1 x plus b2 x square. Now, what is the difference between simple regression and multiple regression? In simple regression, we have only one independent variable, that means we can predict the value of dependent variable y with the help of one independent variable x, while in multiple regression one dependent variable y can be predicted from a set of y independent variables x1, x2 and so on xk. That means, here we see in simple regression we have only one independent variable, while in multiple regression we have more than two independent variables. In simple regression we have only one regression coefficient, while in multiple regression we have one regression coefficient for each independent variable. So, if we have a example, we want to predict the height of a person with the age and gender, then we have separate regression coefficient for age and another regression coefficient for gender. So, in this case we have two independent variable. So, we have two regression coefficient. Third, R square, R is the correlation coefficient. So, square of the correlation coefficient, proportion of variation in dependent variable y predicted from x. In multiple regression, R square, this is also called coefficient of determination, is the proportion of variation in dependent variable y predicted by a set of independent variables x. Advantages of the multiple regression: once a multiple regression equation has been constructed, one can check how good it by examining the coefficient of determination. This is R square, and R square lies between 0 to 1. R square lie between 0 to 1, and for good prediction R must be 1. So, if value of R square is 0.88, then we say 88% prediction, then the prediction is 88%. That means, we can say the independent variable determine dependent variable 88%. In multiple regression, these are the assumption. Multiple regression technique does not test whether dash data is linear. On contrary, proceed by assuming that the relationship between the y and each of x is a linear. Hence, a rule, it is prudent to always look at the scatter plots of x and y. If any plot suggests non-linearity, one may use a suitable transformation to attain a linearity. Now, the third term is standard error of estimate on regression. Standard error of estimate help us to know that to what extent the estimate accurate. It shows that to what extent the estimated values by regression line are closer to the actual line. That means, it can tell us what the difference between the actual value and predicted value. For two regression lines, there are two standard error of estimate. The standard error of estimate of y on x is x y x, and standard error of estimate x on y is s x y. The standard error of estimate to calculate with the help of following formula: s y x equal to summation y minus y c square upon n, where y is the actual value and y c is the estimated value. The another formula to calculate s y x is summation y square minus a summation y square minus a summation y minus b summation x y divided by n, where n is the number of observation and a or b obtained with the help of normal equation. The third simplest formula to calculate standard error of estimate is s y x equal to sigma y square root of 1 minus r square, where sigma y is the standard deviation of the variable y and r is the correlation coefficient. There is an example for practice. Find the standard error of estimate if sigma x equal to 4.4, sigma y equal to 2.2 and r equal to 0.8. The standard error for y on x is s y x and equal to 2.2 into 1 minus 0.8. As we know the formula, s y x standard error of estimate of y on x is summation y under root 1 minus r square. So, summation y is standard deviation, sigma y is 2.2 and r is 0.8. On solving this, we find the value of standard error of estimate of y on x is 1.32. Similarly, we can calculate the standard error x on y is summation x sigma x 1 minus r square, sigma x equal to 4.4 1 minus 0.8 square. This is 4.4 into 1 minus 0.64, this will be equal to 4.4 0.36, this will be equal to 4.4 into 0.6 and this is 2.64. So, this is the standard error of estimate for y is 1.32 and standard error of estimate of x on y is 2.64. Thank you.